Perfect. Good morning, everybody.
Good morning.
Good morning.
Hello. I'm so excited today to be with really an amazing team that inspires me personally as a biomedical engineer, and just to be with the technical college is so amazing. So we're here today with the Illinois Institute of Technology in Chicago, Illinois, and I'd love to introduce our guest today. We have Jamshid Mohammadi, and we also have Keigo. And Keigo, well, let's start with Jamshid. Why don't you give us a little bit about your background?
Okay, thank you so much, Renah, and good morning. My name is Jamshid Mohammadi, and I have been with the Illinois Institute of Technology over the past 40 years, and in various ranks. I started as assistant professor, and right now I am a professor of civil and architectural engineering. And also, I have some administrative duties. Currently, I'm the dean of the graduate college. Also, I run a center called Center for Learning Innovation. And I teach courses in the areas of structural safety and reliability, structural design. And my research focuses primarily on failure investigation of structural systems, fatigue in metals, and also natural hazards effects such as earthquakes and wind loads on structures. And over the past several months that I have been involved with EON, I have a group of students who are working with me. They are developing some teaching assets, primarily application to structural engineering. And we are very, very much excited that we are making progress on that. So.
Fantastic. I have so many questions for you, just because also my husband's an airline pilot. And so we actually watch structural safety videos as a hobby at my house, believe it or not.
Well, that's great.
Like to watch. Yeah. And I'd like to welcome Keigo Kawaji, just one of the most innovative professors I've met around the world. And it's really an honor to work with you. Honestly, it's I think of you a lot, because you have such an amazing imagination, and for an engineer with your visual acuity is pretty amazing. So just have you introduce yourself, Keigo.
Sure. Thank you, and I'm honored to be here. My name is Keigo Kawaji, and I'm an assistant professor at Illinois Tech in the Department of Biomedical Engineering. I also do have a courtesy appointment at a nearby academic medical center, and my research is primarily in magnetic resonance imaging. So this is the clinical MRI scanner technology development. I'm also a faculty member of the Center for Learning Innovations that Dr. Mohammadi leads. And I've been at IIT for the past, I guess this is my 5th year. And I'm currently very interested in not just developing existing courses to become better, but also exploring new opportunities, such as with this EON XR tool, to integrate new technology-driven pedagogic didactic methods.
Fantastic. Thank you so much both for being here. And I think we may be joined in a little bit by another Professor Edoarda Corradi del Aqua, and she's with the Department of Civil and Architectural and Environment Engineering. And first of all, what a great institution to have those fields work together and people being in school together. It must be fantastic for your students to be integrating with all these technical fields, because I feel like right now there's so much integration between all of these things, probably more than ever. I mean, it's always been true, but it seems now even more than ever, students are asked to do things in the work that are really a combination of different fields. So fantastic. So let's start with my first question is, let's just talk about a little bit about the Center for Innovation and what that looks like. So,
well, yeah, thank you, Renah, for asking. The Center for Learning Innovation started back in 2020. Actually, the reason for that was because of pandemic. We switchly moved to online courses back in March of 2020, and after like a couple of months, there was a need by the university to have a center that would sort of organize online courses and providing seminars to faculty to bring everybody to speed. So right now we do a variety of tasks at what we call CLI, Center for Learning Innovation. In addition to having seminars for our faculty members, we also coordinate the LMS activities, questions that faculty have, and we run orientation sessions for new faculty members. And we also produce videos, educational videos on how to use different things. We are pretty much manage the course assessments. By assessment, I mean evaluation of student performance. So we are in charge of those. And we have a group of excellent faculty members called faculty affiliates. That Keigo is a member. They are our consultants. So, and we often use their services in providing us with the guidance, with the directions, and also when we run seminars and the workshops, they are very active participants in those. And both of the faculty members involved with Ian, Keigo and Edoarda are members of faculty affiliates. So at this point, we are moving very rapidly to have online courses and get into what we call the digital Illinois tech. And that's one of our responsibilities, working with other entities on campus to promote offering online courses.
I'd love to ask Keigo a question about that, because I work with institutions all over the world, and I was surprised to see a lot of librarians, coming on my teachings about pedagogy. But it turns out some people do their innovation center in the library. And so they have, have the same resources, right? Find materials, learn new technologies, maybe not assessment, but learning new technologies, doing the videos and things. And so I wanted to ask you, for the benefit of our viewers and librarians and people running tech centers, or maybe even running like, what do you call it, a working space with tools, different technology centers, I guess, how it runs for faculty and how, like how you help people with these new technologies as you come out. I know you mentioned LMS. I mean, that's been a challenge for all of us teachers in the pandemic. So we had to do a lot of things in there that we weren't used to. But just from a faculty view, any advice for people out there, Keigo?
Sure. Well, I guess I'm not sure if I'm directly answering your question, but to kind of frame it in the way I sort of contextualize about it is, I first think about almost everything that we could, approach as a resource allocation problem. How much time does it take to get a task done? And then whenever we're outside of our comfort zone, meaning we've been teaching in class in a traditional manner with this specific class or any, previous class, but now there's a pandemic and we have to adapt. How much resource can we allocate? How much bandwidth do the students have to adapt to new technologies, new tools? Should we introduce so many different tools all at once, or would that potentially disengage the students and become, a negative experience, just because sometimes we have to think about the technologies that we try deploying may not necessarily work. And so in that context, I really think that I guess what I do want to say is that oftentimes less is more, and you really have to prioritize and have a specific game plan to approach it, rather than here's this technology, here's that technology, and this may potentially be the interim solution, but wouldn't necessarily be the long-term solution to the specific task on hand. I guess it's a really generic, very generalized sort of question, not really targeting like library sciences or education in the library setting, or even just encouraging students to, read the textbook.
Right.
And
oh yeah, the textbook. Wait,
right.
My students don't buy my textbooks when I give it to them.
Yeah.
That's still a new problem. Yeah.
I may want to add that the CLI works very closely with our library as well,
Okay.
and also with the technology offices. We are joining forces to sort of optimize our resources to work together in some of the areas that especially Keigo talked about. Yeah.
So one of the questions I have, because the way that I'm like in the institutions I work, we have the softwares that I teach. They might not have them at home. So during the pandemic, we had to use sometimes more generic softwares because they weren't all provided to students. Like Adobe is a great example. Maybe they didn't have a license for 15,000 students or something like that. So on the professors, we had to go and find other things as a temporary replacement. But now that things are coming back, are students then going to be attending like in the learning center and maybe also the library, being able to use the softwares like Eon, different things that and like kind of learn them, get help on campus, things like that? Does that make,
Yeah, actually, yes. Yeah, those are all the resources and helps are available for. There are different entities on campus that the students can go for help, and we have a center for. I forgot the new name, but it is for that purpose, for helping the students. And actually, this is run by upper level students, helping the lower level students like freshmen and sophomores in helping them with their questions that they have. And also they can go to our Office of Technology Center, and then they are very prompt in responding back to students' questions regarding software. And then when we have partnerships with companies, for example, like Eon Reality, and we have another partnership with Trimble for our civil engineering department, and then we use their services. Of course, not to that much of extent with Eon, but with Trimble especially, we use their helpline very quickly, and very rigorously for asking our students to get the help they need on the software that are for specific applications. Yeah.
Nice. Is that like a design type of software?
Right. The Trimble actually is a design, and we were very delighted to know that it is supported by Eon. So our students are sort of integrating the two together, and they are able to create assets using Trimble. Yeah, Trimble is read very easily into Eon. Yeah.
That's fantastic. And I think Edoarda's here. Hi, Edoarda. Fantastic.
Hello.
Live here on the website.
I'm sorry for the delay.
So thanks for being here. Looks like we're all here. Since you just joined, I just briefly introduced you, but you want to give a quick minute background about your what you're teaching? Yeah.
Sure, of course. So my name is Edoarda Corradi. I am a senior lecturer in the Department of Civil Architectural and Environmental Engineering at Illinois Institute of Technology. And my I teach primarily I teach in the engineering school, but I teach architectural design, engineering graphics, and high performance buildings design. So somehow I'm in between the two disciplines of architecture and engineering.
Fantastic. And thanks for being here. I just want to jump right into the MRI world because we have so many viewers that have asked me all over the world about this. And I think, Keigo, you're the leading professor around the world on how you're conceptualizing it, which is why I was excited about this webinar. I'd love to talk about the possibilities on getting assets and how you relate it to things like, I'm just thinking, just from my experience in in hospitals, how you use it to either do like a diagnosis or create a device, or sometimes in nursing, it, relates to nursing practices, dosages, things like that. And you probably have your own thoughts about it. Those are just like kind of my thoughts. And I've done the process of like even looking at MRIs with the software that doctors use and then being able to go through the whole thing. How can we use the 3D world, and you can explain how you do it in either AR, VR, 3D for people, how you use that within like the Eon environment and also maybe in tangent with other tools.
Sure. I think it was about 4 years ago, the didactic sort of education delivery of the anatomy class in the medical school curriculum using augmented reality, virtual reality software, driven from MRI or CT or other biomedical imaging data, was actually a featured plenary talk at a major MRI conference, the premier MRI conference that researchers such as myself, a lot of clinicians attend globally. And I believe this was at Case Western University. where they've led the engineering innovations of incorporating these digital tools. For example, using Microsoft HoloLens to teach anatomy in a very similar sort of delivery mode as what we got to learn and got to play around with ourselves using Eon on our phones.
Fantastic.
And there's a practical, from a practical standpoint, in place of human cadavers that one would dissect, now you could actually do some of this virtually. And perhaps the debate may be, to some extent, what are the good elements of the old, but can we actually save some costs or improve the efficiency or access by pinpointing to the limited resource problem, limited number of cadavers, right? Mm-hmm. Availability of each, decay, and have something that's preserved for a very long time in the digital space through this medium, but also acknowledging the fact that there are some elements that may be present in the MRI, meaning the biomedical image would have it, but would not see that's truly there in the true anatomy or even physiology when you go to the extent of what we are trying to probe. And this is kind of like the trade-off, I think, of where the virtual reality, augmented reality, if it could actually not just go beyond the things that it can see or it captures, but also show what's not seen through time, for example, then I think this will be a huge potential to further improve the education, not only of medical students, but also a wide cohort of students in this practice.
So would you bring those in through, like bring in a 3D model that's an MRI actual image, maybe animated to add the element of time? And then I know you did something really innovative with notes, and I think that was maybe a 3D image, but I could be wrong. If you remember what, you showed me something where it came across the screen in an image. It might have been some notes or something.
Okay. Yeah. I think it may have been part of our research program, and this is something on our wish list of what we could potentially incorporate into, VR, AR, which is if we have a moving 3D plus time, so 4-dimensional model of the heart with additional information such as actually measured, not computed, measurements of flow, blood flow, that is obtained from the patient over an MRI scan. And if we could visualize that, angulate it, tilt it, render it, and or in the rendered space, then I think there's a lot of value to potentially see beyond what clinicians or even the people in the medical space are familiar seeing, which is a matrix of 200 by 100 and something by 60, or interpolated to 100, that shows this volume, and you scroll through and you can only see a single 2D image. And you also know that the data size that is contained in this matrix over time is just enormous. That processing and rendering and visualization is so resource expensive, that not everyone has immediate access to. Right.
Totally get that, and I learned that when I was trying to render a bunch of images here, and that's why you need that special software. But if you get it like in a video format and you can measure volume, that's always been a challenge for us in biomedical engineering, is to measure accurate volume on different substances with different viscosities, which then inform how you design medical devices and so forth. I mean, that's the field that I worked in. So yeah, I agree with you. It's but I think that we're at the point now where we could bring in images, rotate them around, and then use those for learning. And then volume information is, I think, that's something that right now it's harder to get. Well, I mean, you have to get it through in live imaging, and then probably add it into things for, if you're teaching students, kind of add it in as a kind of a knowledge portal, I would say, maybe. That sounds right. Okay. Anything else helpful for people working with MRIs and AR, VR out there? Sources, anything you can help with?
Well, there's a lot of innovative research happening in the MRI community that's actively looking at specific subdomains, whether it's from data acquisition, data reconstruction, or further clinical visualization, or even assessment. As you said, could you quantify volume? Now, with the emergence of artificial intelligence, can we train a computer to segment out, let's say the blood chamber So how much volume there is in the left ventricle, which is one of the 4 chambers that pumps out the blood to the circulatory system in the heart. And first, using what doctors would delineate by drawing lots and lots of circles as a reference. But can a computer do that and make that process more efficient and seamless? So these are some of the, further applications that could be highly compatible with this augmented reality, virtual reality type system. Maybe in like 10, 20 years, when we have all the principal technologies that can run smoothly on, and the computing problem, meaning the time it takes to visualize is addressed, then we could probably do some real time, meaning during surgery, you actually collect the scan, you render it, you have a digital twin model, for example, something that replicates the patient's actual heart or, vasculature, blood vessels, or any other, anatomical target, and help guide the surgeon who actually gets to not just see, but also visually interact.
Absolutely. I'm just going to share a quick screen, just to show people like what things look like out there. This is just what we're talking about, like a heart model where you can, rotate. This is an actual animated model, but you can teach students the different, ways that things work. I mean, this is a lot different than the way that, of course, we went to school, being able to learn about flow, the vessels, the chambers, and all that. So it's a very rich experience. So that's an EON with one of our partners at a hospital called Chalk here in Southern California. So so let's see if I can unshare my screen. There we go. So and I think that's just a different way of learning for students. And I think being most of us learned kind of in a 2D world, and unless you're alive in surgery or something like that. So really good points. I want to jump to Edoarda, who teaches something completely different, yet related, because we're all engineers and we all took all the same courses and structures and everything. And in fact, all 4 of us have that in common, is the core of what we learned. That and I want to just ask you. I have so many questions about architecture. I attended a session with Adobe a couple of years ago up at Apple, which is one of our partners, where we learned how to take iPads to the architectural site of the future and then design there on the site, so you can kind of imagine how things look. And in 3D, the architects are good are already, of course, drawing and everything, but and I know Keigo mentioned bringing assets from one software to another. I do that with my courses sometimes from Blender and Unity, and bring things in different. So because I teach video and audio, and so some of those things, Adobe, different things come in. So I was going to ask you how you're perceiving using EON with architecture with your students.
Yes, of course. So what I think one of the strengths is that with EON, through this platform, you can really, or students can really kind of experience the space or a building, an architecture. They can, they can rotate the model. They can enter into the space and see the interiors. So they can really experience this rather than seeing building just in maybe 2D representations, such as floor plans or sections, or even a rendering maybe. So I think the strength lies in the fact that it's very dynamic. I actually introduced this software to my engineering graphics students. These are freshman students, so they are learning how to use different drawing softwares such as AutoCAD or Revit and SketchUp. And I asked them to work on an assignment in which they were required to create an experience using one of the provided models, and then also uploading one of their own drawings and assets. And so we did a 3D model with SketchUp of Crown Hall, and the student imported it into EON, and they were able to explode the building and split it into its different elements, of course, depending on how the model has been created in SketchUp. So that was a very interesting learning experience, I think, for us.
Yeah, I think.
But I can see the potential of, like, depending on how the model is created, of how you can really really explode the building in its units and elements, and be able to visualize it like that.
So you really, for structural engineering, really need to look at this. I mean, the original bones, the original structure, and and then all the calculations based on that, and then all the layers. So I think that's the challenge, and that's the challenge that I'm going to give to designers out there who are watching this. That those are a great way to build models for architectural students. If you have you can get down to the first layer. So, or if you import those from other softwares where you're designing an architectural site, and then bring it in, where you can separate the layers all the way down to that original structure. So,
right.
Fantastic. So what is that like when they like look through their device or something, and then go into like a 1-to-1 scale and walk through there? How do students kind of react to that? Because the first time I started doing that, I was like, that's pretty amazing. Like you can do things like as big as a house or any other building. It's a different experience for me. Yeah.
Yeah, I mean, I think they had a lot of fun in class, exploring all the different features, and also being able to. I really like the feature where you kind of really enter into the space, and also with your phone you can kind of turn around, and you are seeing all the different perspectives. So I think the students really enjoyed it, and we will talk more about it. We are still in progress. We still have 2 weeks more in the semester, but I mean, so far I've had a positive feedback.
It's it just reminded me, because I do some of my demos in my park that I live by, and just bringing my phone and then doing AR over there and looking at what something's going to look like in that environment is pretty mind-blowing. I think that's my most fun way to use it, because it really brings the worlds together, that virtual world and that real world. And in architecture, of course, that's super important. And and an iPad is perfect for that. Actually, then you can sit there and draw, and then you can look, in AR. It's
one of the areas, Renah, that our students are experimenting rather, is how big a structural members they designed are, because when they do it on the paper, they just don't realize that in relation with others. But once they put it into a 3D, they have a very good idea that, they can look at their design and say, wow, this was too big when I designed, I have to change it. Or, going back to Edoarda's expertise, that when they have to pass ducts through a structural members or pipes. And I was listening to their presentation of a group this past Thursday, and they were talking about how now they have a better visualization of where to cut these structural members to pass a pipe through, or an air conditioning duct through. So I think these are the areas that in the past, it wasn't possible, or if it was possible, it was not that easy, but they had to draw things almost like a full scale to figure out how to fit things together. But now very easily we can pretty much do it with the virtual reality and make necessary changes to help them with their design. Yeah.
That's fantastic. Scale is a huge thing. I mean, teaching students big things, small things, things that they wouldn't be able to even perceive. And it reminds me of a lecture I did recently at USC, and I think it has to do with what you teach, Jamshid. I was showing the inside of a Boeing cockpit to master's and doctoral students in aviation engineering. And they said, because it had all the components in there, and it was a scale accurate from Boeing, you could see it in the goggles or on your phone or whatever. And they said if they had seen that, it gives them a completely different perspective on the design of safety systems.
Absolutely.
So, and that was kind of like, I really heard that because I didn't think like it would have an immediate impact on the perception of students and the way they think. And that's not kind of a response I expected, that it would impact their way that they think about systems and safety if they could rotate things around, see where they're positioned next to each other in scale and things like that. So I don't know if you want to talk about that for a second, because that's your specialty.
I think, and exactly. when you get into, actually, I have done some work in the area of aerospace engineering, and because the structures, after all, are structures, an aircraft is, fuselage is a structure. In one of the areas that I was working on is what we call metal fatigue, and that happens especially a lot in the aircraft components. And when you look at the structural member, which is prone to that kind of failure, that's where you could zero down and increase the size and look at the critical areas. We call it hotspots. Those are the areas with what we call stress concentrations happen and may trigger some crack growth and development. So those are the areas. There have been some software developed by various companies, especially United States Air Force, and some of those are available free, but they are very crude. They don't get into the absolute details. So when you look at, for example, a structural member in a body of an aircraft, is usually a curved member with a lot of holes because they cut a lot of metal to reduce the weight, and a lot of fasteners, we call them rivets. And so now, with the help of a finite element analysis and the virtual reality, you can actually walk into fuselage of an aircraft and you look at these areas, just like when you are doing an inspection. So these are the areas that I think are really open the door to a lot of opportunities for learning for our students to know exactly what's going on in terms of getting into the areas that they are prone to failure. So I think this is where I can see the applications could be huge.
Fantastic. Yeah, those, I'll bring one up in a minute when I get my PowerPoint back up, but those models, I think were maybe one of the first surprising things for me in AR, where I could place myself either in a driver's seat or a cockpit or something, and then kind of learn everything like in true scale. And if you do it in goggles, it's even more like incredible. And I think that's our job as teachers, is really student engagement. We know, and that's my next question, has been challenging as students now get information in seconds. And they didn't, it's like, why would I open a book when I just ask Siri or something like that? So I want to ask you how you think students are different, like multitasking, their attention span, their online access, their phone access, and how you think that AR, VR might help maybe with student engagement or other things. Maybe we'll start with Edoarda, since you just popped back up.
Thank you. I think it can help in several ways. One way is certainly student engagement, because of course it's also fun for the students experience. And I think the other, I mean, at least from my perspective, since I teach engineering graphics, I notice that students sometimes have a hard time understanding 2D drawings. I'm talking about freshman students, clearly. It is sometimes a little bit abstract to them. So having the ability to see it in 3 dimensions and then compare, I think, the two views and really understand, okay, this line represents this edge in the 3D. And they also can turn it around and see it from different point of views. I think that will be very helpful, and it will really make the drawing real. Sometimes I have the feeling that when they are visualizing a section drawing or again a 2D drawing, they don't quite understand what a line is. Like it seems, a little abstract maybe as a type of representation, and so that will be very helpful to compare, I think.
I think going back into Renah, when Edoarda talked about this, reminded me of my drafting course back in college, and of course we didn't have this kind of information. So one of the most difficult part was especially we had this kind of difficult parts as part of the exams, that they give you 2Ds and they said, well, you have to visualize how the 3D would look like out of this, and you have to draw it. And that's what a lot of students failed, because they couldn't relate the two. But now our students can very easily go to the library of various software and find out exactly how these things would look like, when they see the 2D images. So I think these are, you're talking about attention span of students is, that's, a lot of these opportunities give students the quick way of learning, and that would help them a lot with their cognitive behavior of now understanding how this 3D would look like. And I remember that was one of difficulties we had, try to find out and guess that how does it look like from only they gave you 2D plans, and they said, well, you have to think about how the 3D would look like and do sketches of it. So now you can see that how long we have come with these opportunities that we have.
I totally agree. And Keigo, this was my conundrum and I like puzzle solving. So bioengineering combined chemistry, which I didn't understand until I became a chemist. And it just didn't relate to me on the calculus to reality, right? It's like calculus to cooking until I started doing it. And then it's like, oh, I get it now. And then combining that with body, the human body, and then combining that with creating devices and working together. So for your students, how do you perceive kind of it prepares them for jobs of the future in a difficult field that's so integrated like bioengineering?
Yeah, I would say biomedical engineering, there's a general perception that the field does not specialize, such as electrical engineering, mechanical engineering, chemical engineering, or even civil and architectural engineering in some ways, because as you said, it covers a very broad spectrum. Even the undergraduate curriculum at many schools, including ours, we have students doing additional science courses to the bare minimum requirement to become an engineer, such as biology and advanced biology courses, chemistry and advanced chemistry courses and such. So that's not necessarily required in the other engineering disciplines. And again, from a resource allocation perspective, that takes up space on what they could potentially learn otherwise. So even in BME, we do subspecialize into, for example, at IIT, we have 3 undergraduate tracks, cell and tissue engineering, and the students who really want to pursue that would take a dedicated set of course sequences that really prepares them well eventually. And then there's also instrumentation-based neuroengineering, also in biomedical imaging track, that we also have. Both are somewhat similar in terms of the courses that we offer and the sequences that they complete. But these oftentimes become very complementary to really build up the requisite skills that's ideally marketable to the specific domain, where we ask the scientists, for example, for cell and tissue engineering students, they may look at companies such as Abbott or Merck or, pharma-based or even some medical devices-based companies. What are the skill sets that's needed? And then the students would subspecialize and kind of pick out what's potentially marketable or useful for there. Likewise, with medical imaging and neuroengineering, we have a similar sort of trend where the students are already trying to develop domain expertise in something that's pertinent to one specific subfield. But I think this is generally true to some extent in all disciplines, such as in how we already distinguish between civil and architectural engineering. So it's basically the same in that sort of context too.
Yeah, so because I was in medical device design, so I'm always challenging myself to think of how I can take something I design and put a model and then a second model, and then see how I can study an interaction in VR or AR. So I think for me, I think that's where we're going, where you have, we're doing that at EON too, where you can put it, it's going to be initially 3 models, but different interactions, because we're talking about different fields and different things that have to interact together. Like you said before with, we're talking about, fluids and flow rates, fluid mechanics, versus devices or versus, a human anatomy and physiology and how these things all interact. So I'm just thinking about, preparing students for that with new types of modalities in AR and VR. So, yeah. So how about, Edoarda, on the same subject for jobs of the future in architecture, what's changing now with these new technologies for students and the way they're learning? I'm not sure.
Sorry. Yep.
No, go ahead.
Here I am. I think, I mean, I can see applications in the professions, not only related to students, also like in the profession, I can see it as a way to maybe help the clients visualize a project, for example. Like I can imagine, like as an architect, you want to show your design to a client. Not everyone has the ability to, as Professor Mohammadi was mentioning, visualize and understand a 3D space through 2D representations. And so like providing this type of visualization and being able to experience the space again, it's something that I could see having a potential. In education, again, my opinion, like the biggest potential, the biggest strength that it has is the fact that it's dynamic and it provides a different type of visualizing space. And you mentioned scale. That's truly important. Like with this in architecture, and I think with this type of visualization, students can probably. Students younger students can also start understanding, okay, what's the scale of this building? What's compared to the human scale, for example? Or so I think that it provides a lot of opportunities in that sense. Yeah.
Fantastic. Let's talk about maybe some of your favorite use cases. You've been on EON for a little bit. I have kind of my favorite things to do, which is really, I do love scaling things like really large and learning that way, even if there's like, I love cardiovascular studies. So just being able to walk through a beating heart and see where the valves are, which direction then to me, that's exciting because I got to see it in a book until I saw it live. But even when you see something like in a surgery, it's, from my viewpoint, 'cause I'm not a medical doctor, like it's not so easy to understand, it's kind of messy, but to see a 3D model, like it kind of brought things together on like when I'm thinking about device design. So I'm just wondering, like, do you have some favorite ways of using EON or AR/VR that you like, that you want to talk about, or use cases maybe?
Sure. Let me start with a quick anecdotal story of when we worked with a cardiac surgeon who basically was handling a heart that we got from a grocery store butcher for trying to actually see what it looks like. And the shape of the heart, when it's excised, meaning when it's outside of the body, and this is not a human heart, but a pig heart, I think, from the grocery store, looked quite different. And the surgeon, although with decades of experience and expertise in doing surgery on the heart, could not really tell which part of the heart was where.
Wow.
Right. And this gave us the intuition that, okay, there's probably something that they're familiar with, meaning the orientation of the view and how they access the body when they're surgically looking into the patient. And then oftentimes there's abnormalities of, in some patients, the heart position might be quite different geometrically from most of the patients that come through. Now, one of the things about MRI research is that we could actually get images beforehand to help guide the patient, or help guide the surgeon, so that there's more informed decision making prior to opening up. The parallel I take, or the take-home message I take from this, on how to reduce the anxiety or bring a lot of familiarity prospectively, meaning before we actually get into the nitty-gritty, from an AR VR type system, is it's almost like if you have a simulation model of anything, whether it's how does heat or mass, or in my case electric charge, conduct through a medium, then you could actually have students sort of visualize that and develop an intuition before they go into the nitty-gritty equations of what that entails. And sometimes having that context and what you're looking for, right, as a target, is really helpful in them trying to actually, solve the sets of equations, or do the sort of mathematical the techniques that we want them to actually practice to accomplish a very strong result that's common across all engineering disciplines, right?
Yes, definitely.
And that's really one aspect of just being able to, I want to say, intuitively or pre-rigorously trying to develop that intuition or internalize basically a non-trivial subject matter or material ahead of time. And that's really where the deployment of such tools, or even YouTube videos that are linked from these education modules, are very helpful.
I love that. Scale was one of the things that was tricky, and in bioengineering, when you work with people in different parts of the world, the scale changes, especially with hearts. So I spent years just working with the Japanese market, designing things at different scales. Is fascinating. I love that story because I totally relate to that.
Yeah.
Jamshid, any?
Again, I want to, very similar to what Keigo was talking about, is the issue of knowing actually how it looks like when something is in place. And one of the difficulties our students have is regarding what we call connections or joints, how a beam is connected to a post or a column. And just this past Thursday, I was discussing those with my group in the project, and I noticed that they still have that difficulty. They just can't visualize it. And, that is where we can concentrate and say, look, this is how it looks like. This is how it is connected. These are like bolts or welds that are used. And now you can see that how difficult it is to fit the two together. And especially the variety of assets that are available. Keigo mentioned YouTube, and I have seen some YouTube videos that show actually how you fasten the bolts and put the two connections together, and those that I was telling the students, they can utilize those and attach it to their product. And therefore, you already have a clip in there that shows students that this is how it looks like. And then they can come back and look at this other component. So again, it's pretty much being confident that the student understood how these things would really look like when they are in place and attached to another structural member.
Fantastic. One of the things reminded me when you were talking that I came out of the paradigm myself, because I've been using the LMS systems, personally Blackboard and Canvas for 25 years. And so we learned to, as teachers, put our lecture content and everything in there. But I started to realize, I think, Keigo, you're the one that turned me on this, that I can do it right in Eon. So because I've always put my things on YouTube. I figured, even I put it public, I figure no one's going to watch it besides my students anyways, but I could make a private link. But to be able to talk to students in give short lectures or whatever I want to do about different topics in that experience so they don't leave, I think is a really good way to go, so that you don't leave the immersive environment and you can just be listening to that while you're interacting. I kind of think that gets the goal of like using both sides of your brain, you're visualizing, you're hearing, you're learning, interacting all together. And I started to realize, okay, even in Eon, we can record the name using audio of every label so that you can hear it, you can see it, you can turn on closed caption. You can take practice quizzes, whatever that you want to do. But I think just bringing my own content, or sometimes I have my students make videos and I say, bring in your own videos. So any comments on that? I mean, to me, it's a paradigm breaker because it's not an LMS system, right? I'm not saying that, but it definitely keeps you in that environment with that content that you used to only be able to put in your LMS. Anybody? I know, Keigo, you're the one that, like I said, turned me on to that. So
Sure. I could comment a little bit from my perspective too. So for my research, I develop new techniques on the MRI scanners, and therefore, as an extension of that, I broadly have lots of interest in what's called systems engineering from a more software oriented perspective, but also accounting for what kind of unique hardware there is. That's an MRI scanner is a very complicated machine with 3 CPUs, perhaps a graphics card and such, that cannot afford to break down mid-scan. right? And the extension of that into what's called systems integration is when you have multiple sort of features that you want to run concurrently, simultaneously, and in this case, we're flipping a patient scan with effective education delivery to students in a very engaging manner, and also accounting for what are all the parameters of the limitations of, let's say, the online delivery of the existing class. Let's say if it's online teaching, well, with for example, even in this webinar, we can only have one person speaking at a time, right?
Right.
Now, the real advantage of this embedded sort of systems with all these tools from a single platform is you could actually then outsource to each student to, have a flipped classroom. Well, try the AR, VR activity, and then come back after a breakout session, which is now becoming more of the norm. As we became familiarized with it. And there was actually, from the instructor's perspective, there was actually perhaps an iterative process that we could see in whether it's vendors like Zoom or Google or whatnot, Blackboard even, they had to actually develop some specific, features to enable these, tools that are widely desired by the many, meaning whether it's instructors or students. And on the flip side, there's also the side note about how some students don't update their software. So then you're allocating, dedicated class time to, reboot your, so meaning there's IT troubleshooting to make sure that the what's carefully prepared would hopefully run on the student's computer or on everyone, who's participating. And these are all additional new fun problems to really think about, because now we're really thinking of the whole system of how will this cohesively work, almost as if it were an orchestra. When before doing any of this, for the same content delivery of a lecture, I'm just thinking about what's on my lecture notes and how to portray and pace the lecture on the whiteboard. Right? So I think there's a lot more multitasking, but also for the benefit of the student to really be more engaged than just memorizing, regurgitating. And I started seeing some trends such as, the current college students, they just take a camera snapshot of the whiteboard after it's all written, right? And say, well, as long as I have that, I could someday go back to it, handwrite it myself so I learn better. And whether, some students do that or not, it's really cast upon them to leverage, the extra time that they have, meaning, these are all the thought process that goes into, I think, deployment of one new system. And it's really fun.
Interesting.
Much smoother.
Yeah, student engagement is huge right now, as we've seen declining enrollment across a lot of colleges. And I just think, because people can go and learn, and just to keep, us as professors in the loop and leading that charge and keeping them engaged is so important, I think. So many questions, but we're running out of time. So let me just run to any last thoughts on AR, VR that you wanted to, maybe I didn't ask yet, or that you wanted to talk about, or you thought about before we hopped on here. Let's start with Jamshid, because you've been kind of leading this for your entire institution wonderfully. And I know you've had a lot of ideas.
Well, we are hoping that after we implement some of these applications, to go back and see how students would feel about it and have a little bit of assessment. So we have a better feel that, how students thought about it. And it looks like right now that they are very excited about its opportunities. But we would like to do more like what we call, in the absence of any word, formal assessment of a student's experience with Eon reality and augmented reality. So that is what our center is planning to do. And I'm hoping that this application is very successful, so we can extend it to other courses and encourage our faculty members to develop in different areas. Right now, we are just focusing on pretty much 2 areas, but there are a lot more that we can just go ahead and implement this. So that is my hope, and I'm advocating is very much. Yeah.
Fantastic. Edoarda, any last thoughts on implementing AR, VR. That's what I do, is help implement. And any thoughts on how that's going? Or
yeah, I mean, I hope to continue implementing it in my courses. I like that we talked about student engagement, and Keigo mentioned how students take pictures of the whiteboard. And what I like is that this tool is interactive. So it's not like taking a picture of the whiteboard. I mean, yes, then maybe if you're good, you're taking notes later and you will actually learn the material. But with this feature, with this tool, it's interactive. You can rotate the model, explode it. You can look at the quiz. You can listen to videos, or go through a whole lecture in an interactive way. And I think that will just keeps the engagement, keeps the students engaged. And then going back to what Jamshid mentioned earlier, like the ability of seeing how all the different elements and systems, at least in my field in architecture, interact within a building and interact with the people experience, the users experiencing the building. That's a big potential.
Okay, I'm going to ask you a slightly different question, because I didn't hit on it yet, but I don't want to miss it, on digital twins. And maybe Jamshid has some coming on there too. I just find it revolutionary what's going on in industry right now, where they're using it for process improvement, using sensor technology in a digital twin, or city optimization and urban planning. That's more Edoarda's area. But where do you put the parking lots? Where do you need to widen the streets? Where do you need to change the buildings? Because you can do a digital twin of an entire city, and then using sensor technology, gather data, and then make decisions like that. And so it's a amazing change in process improvement, quality improvement. So, and I think in engineering, in all of our fields, it's gonna continue to kind of revolutionize QA and process improvement. So, Keigo, do you have any thoughts on digital twins?
Yeah, I really think the game changer of the digital twin platform, just at large, is the cost effectiveness. Meaning, oftentimes research or all these innovations are expensive when we deploy it, when we scale out. And to be able to do that in a fairly low cost, meaning the cost is, I think, more computational, right? Oftentimes digital twins refer to a digital sort of medium that's highly elaborate, meaning it's complex with a lot of rigor that reflects the reality, such as some of the PowerPoint models that you've shown with time lapse of a beating heart, for example, right? And to potentially have that, and the next level of just the generic heart that beats is what I want to call like the precision medicine digital twin of a specific patient, so that it helps with the surgical planning, it helps with the sort of the preparation that's really curated, and then you can optimize within that space. And then some of the general trends that you see, maybe not necessarily the best, but among the best, would also translate in reality. And we could actually do that without the trial and error, or identifying the faults and actually taking that risk when failure could be catastrophically expensive, basically. And I think that's a key feature that I think is definitely a draw for all engineers, in fact.
Absolutely. And digital twins is a little harder to understand in kind of the non-technical sense, but in QA is a basic part of any engineering job. So, like, since we're having this more technical discussion, I wanted to bring that up. And Edoarda, I just wanted, since I'm talking about architecture and urban planning, do you have any thoughts about, kind of optimization and future cities with digital twins, or maybe even just architectural design in new spaces, things like that?
Let me think about the answer.
I was in my head, I was thinking like, okay, you have a city that's growing, and then you have to demolish a space and then rebuild something, and you found that out because you had sensors in your digital twin about the space, and you're like, okay, this area needs to be updated or whatever, for whatever reason, and then you would have to go there and like design something for the for now and in the future. But you getting that technology through through a digital twin. So you're sitting in some office somewhere in your urban planning and getting data. And they're like, okay, I'm going to send an architect out there to design something because now we need to demolish the old thing and do a new thing. So that's kind of my concept of it in architecture.
Yes, and probably this could go also in many directions. I'm thinking also about energy and sustainable cities, and how we gather energy data, for example, within the cities. That could be done through I have never worked personally with a digital twin, but I could imagine that could be one of the possible directions that it could go and see. Yeah.
That's a beautiful answer. I mean, that's exactly like a perfect example of a digital twin in architecture. Yeah, and updating to like a more green city.
Yeah, so thinking about the urban scale, not necessarily only at the building scale.
Fantastic. So. And final question goes to Jamshid. Any last thoughts? And I wanted to just thank you all for being here today.
Oh, sure.
And I hope you enjoyed this conversation. I certainly did. I could talk to you all for several hours.
No, absolutely. Yeah. I'm just going to emphasize the digital twin application. Recently we had two major failures. One, of course, last year with the Miami Shore, the apartment building that came down. And we are still scratching our head at what caused it. Nobody has been able to pinpoint to that. So that is where I think the digital twin application would come in. That there is a conference in Hanover, Germany, this coming September, which I have a paper on that's pretty much along the same area, how we can utilize digital twin of a structure to investigate that what were the uncertainty areas that we need to answer. If we change it to something else, what would happen? So I can see that there are a lot of applications. When I brought it up to one of my graduate students who actually graduated already, she was so excited and she said, I want to continue my work in that area. So I think it is huge, and it is at least in my area of failure investigation, I can see a lot of applications, and personally myself, I am pursuing it. And I know that there has been some interest among our students on that.
Fantastic. And I just want to say thank you and congratulate IIT, our partnership with EON, and for our worldwide audience. And this is a webinar that I've been excited about because there's just so many great ideas. And I know a lot of our audience have been asking about these particular subjects. So thank you so much for being here. We're going to be on YouTube, podcast, social medias. I'll be sharing the links shortly. And just thank you all and look forward to working together and changing the future and having fun with our students.
Thank you so much, Renah, for arranging it. It was fun.
Thanks, everybody.
Thank you.
Thank you.
Bye-bye.
Thank you.